Alright, so okay, before we talk about the pointers, this is one of the topics in C language. But before we proceed with that, let me review some topics about what we have discussed last time. So we discussed about the arrays, how to declare single dimension arrays, and I also explained about how can we declare and display the elements of the array when it's in 2 dimension. And specifically, we focused last time on multiple or multi-dimensional arrays. Okay, and also I have given you some examples. For example, how we can add the rows of a multiple array. For example, a 2-dimensional array, how can we add the rows? How can we take the sum of the rows and the sum of the columns? Okay, and then after that, we discuss about the that's it. I think that's the topics that we have discussed last time. So today I'm going to continue with that, and before we proceed with the pointers, let me have some additional example on multi-dimensional array. No? Let's say for this example, we will be having a problem that we'll have to multiply. If you remember, we have if you remember last time, I have shown you through PowerPoint presentation how we can multiply an array to another array, right? So this is what we're going to do using the programming, no, of the C language. So the concept of our program will be to enter the rows. Okay, we will enter the rows, and then after that, after we enter the rows, we're going to just a minute. So after we enter the rows, or first we need to identify the rows and columns of the array. For example, we can have a 2x2, a 3x3 arrays, okay? And we need to identify 2 arrays, okay? So this is for 2 arrays. Okay, so we need to enter the rows and columns of the arrays. So this, for example, we have array A and array B. Okay, so this will be our program, and then after that, we will enter the elements. We will enter the elements of our matrix. Okay. So after we enter the elements of our matrix, what comes next is to identify the elements of the matrix or matrices, because we have 2 arrays like A and B, and then we will display the resultant matrix after multiplications. will be the content of the program that we're going to have. Okay, so to start with, so of course we need to write here the preprocessor, which is include stdio.h. Okay, and then we need to create the main program. Alright, so after that we need to define our variables. Okay, so let's try to initialize some variables. So we need to initialize our array, okay, for array A, for example. So we need to provide our array for that. Let's say it's the array is a two-dimensional array. Okay, this is for array A and as well as for array B. So let's copy this, and this is for array B. Alright, so we also need to include our the rows and the columns. So we need to provide the rows for A. So let's call it A rows. Okay, and also we need to provide the after the A rows, we need to provide for the columns of the A. Okay, so this is for our first matrix. Okay, this is for the first matrix. So we have already have this, so we can copy this one and create similar for our next array. So this is B rows and B columns. And then let's try to stop from there. We need to get the product, right? So we need to introduce another variable called product. Okay, and that product will be a product of columns or rows and columns, no? So we will have a product of a two-dimensional made up of the rows and the column. Alright, and we also need to provide the sum. We're going to need a variable called sum, because if you remember in the PowerPoint presentation I presented last time, in the multiplication process we need to multiply rows and columns elements, and then after that we need to take the sum of all the products. So therefore we need to have a sum. Okay, let's initialize the sum to 0. Okay, and then we need some variables for the looping. So we need variables like I, J, and K. So I think that's gonna be it. This is for the variable declarations. So I'm putting some comments so that you can understand it. Now let's try to have the part 1. This is the part 1 of the program. And the part 1 will allow us to enter the rows and the columns of matrix A or array A. Now this is for the part 1. So the part 1 will be to enter the rows and columns of matrix A. So how do we do that? Very simple, just use the function printf. Okay, and let's say enter the rows and columns matrix A. Alright. So that's it. And then we use the scanf so that we can store the value of the matrix, or the value of the rows and the columns of the matrix that the user will have to input. Okay, so let's say %d, right, and then %d, because the user will have to input the rows and the columns. So we have this first %d is for the rows, and the second %d will be used for the columns. Alright, so we have to put here, this is for, we will use the ampersand indicating we are pointing it to the A columns. So we copy this, and another one will be used using another ampersand, and we copy it for the sorry, that's wrong, no, it should be this one. Okay, so it should be A rows, sorry, and the other one should be A columns. Right, so that's gonna be the how it's gonna be presented in the scanf function. So meaning whatever the user inputted here will be saved to the variables rows and columns because of these formats that we are asking for the input of the user. Okay, and then we'll use another printf function to enter the elements of the matrix. Okay, so the user again will be asked enter the elements of matrix A. So the user now will have to enter the elements of the matrix, and let's use \n so that the user will have to enter it on another space or another line. Okay, so after that we can now create our looping statement. So our most basic looping statement for how many variables do we have? So we have rows and columns, right? So we will now have to use 2 for loops for that, no? So that we can access the rows and the columns. So we will use variables I and j. Okay, let's try to do that. So for I is equal to 0 and I is less than our rows, so we are talking about A rows, okay, then I plus plus. That's the first loop. For the second loop, to loop on the column, we need to use the j variable. J is equal to 0, and if j is less than the columns, right? So we want to put here the A columns, then j plus plus, and another grouping symbol. Okay, now after this, okay, since the user will have to enter all the rows and the columns, we need to put those rows and columns that the user inputted into our matrix. Okay, so we need to use the function scanf and use the %d and use the ampersand symbol so that we can use it for our array A, no? And then the elements of the array should be the I and our j, which is, this is for the elements, all the elements for the rows, and all the elements for the columns. And then it's done. Okay? So that is for inputting. That is for the part 1, no? For the part 2, we need the user to enter the rows and the columns of matrix B. Alright, so that will be, let me copy this one and paste it here, but this time it's for matrix B. So what will be our program? We just copy this one, this part, and paste it here, and let's change this to B. Alright, and then of course we need to copy this one, because basically what will the user input will have to be placed into a variable. But this time we're not using the A variable, but we are using the B rows and the B columns variable. Alright, now it's not enough that we have done this and do this again, no? Do this again. Now we need to have a testing here. Now if you remember in our last presentation, I will show you the presentation. I think this is the presentation. Let's just wait for the slide to. If you remember in the presentation, okay, we need to know, to identify whether, because this one is very important, right? We need to identify if the first matrix column is equal to the second matrix row, because they should be equal, they should be similar, otherwise we cannot multiply them, no? In this case, if the column's first matrix is not equal to the row's second matrix, they cannot be multiplied because they are unequal. So that's why in our program we need to determine if the matrix A, we're talking about, we can identify in the matrix A, we're talking about the columns, whether the column of matrix A and the row of matrix B are the same. Otherwise, we will say that they have unequal matrices. Okay, so how do we do that? So we can make an if statement stating that if the B rows is not equal, okay, it's not equal to A columns, because we are comparing, we have to compare the B rows to the A columns, right? So we need to make this condition. So we will now print, if this is true, we will now print and display that we cannot continue because they are unequal. Or we can say, we can just say not equal rows and columns. Okay. Else, so what can we say? So we can have an else here. Let's put the else statement here. Okay. We can print. Now we can now print enter the elements of matrix B. So we need to copy this one and paste it here, but we have to change this one to B. Alright, so basically the same lang yon, no? Now we need to scan, we need to use this loop to scan and save it in our variable B. Okay, so we can copy this part. Okay, right here. Okay, so we need to use a for loop, but this time we're not talking about A rows, so we need to use the B rows. So we need to change this to B rows. Okay, and then we also need another loop, and this time we're copying this, but this time we're taking on the B columns. Alright, and finally we can use this scanf. Let's just copy this so that it can scan, or it can save the values that are accumulated in the loops. Okay, so this is our part 2. So we have the part 1 taking on the rows and the columns of matrix A. For the part 2, we need to enter the rows and columns of matrix B. At the same time, we are testing if the B rows is not equal to A columns. Okay, so if this is true, if it is not equal, it will say, oh, we have an unequal rows and columns. Else, we will accept the condition that we need to enter the elements of the matrix. Okay, so after that, we can now proceed with the part 3. And part 3 is to multiply the matrices. Alright, so this is part 3. How do we multiply? If you remember, in our program, we need to loop 3 times. No, we need to loop 3 times. So we are taking on our arrows and columns and rows, and we're going to take the sum. Okay, after we multiply on the arrows and the rows. So we can use a for loop here. Okay, so for example, for I, so we can copy this one and paste it here. So but this time we are taking on our rows. Okay, and then copy this, and then we will have another loop inside. This is for B columns, that's right, we will not change it. Okay, and then another loop will be used for the B rows. Okay, so we are using one rows only here, but here we're going to use the column. But for another loop, we will use another variable called k, which is equal to 0, and then if k is less than our B rows, and then k plus plus, and then we will use the scanf function, this one. Actually we're not, no, we can just state that after that we can take now the sum. Okay, so the sum will be equal to the sum plus, so that is sum plus equals to the first array, okay, which is equal to I, and the other one is for the k. So we're taking on the values of the I and the k. So this is the I, which is the rows. The k will now act as the column. Okay, and then we multiply it to our second matrix, and we're using the k as the rows, and we're using the column as j. Okay, that will be our sum. And then after that, so after this loop, okay, we can take on the product of I and j. Okay, we can say that it will be equal to our sum. Okay, and then this is very important because every after loop we need to initialize the sum to 0 so that our answer will be correct. So we need to put sum will be equal to 0. Okay. Finally, before we can proceed, okay, after the product, we need to print. This is the last part, no? So the last part is to print the resultant matrix. So this is the last part. So let's try to do that. So we use the function printf, and let's type resultant matrix. Okay, and then we use the \n to enter on new line. Okay, and then we print now the resulting matrix. And by doing that, we need, since we have 2 by 2, we need to have another loop here, no? So we will use another loop to print our resultant matrix. So we will use the rows, okay, and we will use the columns. So now we can print, okay, %d, and we will be using the variable product. Okay, this is for the I and for the J. Alright, so that's it, no? And then maybe we can, at the end of every other loop, we can make a statement such as \n, so that the printing will be every after another new line. Okay, so let's save this. So this will be the matrix multiplication. So let's try to run, and let's see. Oh, there's a problem here. So the problem here is that we need to put something inside this variable, and we need to define something that will be the content of this variable. If you remember in your hands-on activity, you need to define something inside this parameter of the array. So for example, we can define here a variable called max. Oh, this is actually a constant. We are defining it. For example, a max of 50 size, maximum of 50 size. So we can now use this max so that it can be placed here, no? And also we can use it for the product, so that all the contents of the arrays should have a maximum size of 50. Alright, so I think we can run this now. Okay. Oh, what is the problem? Let me see, and let me check what is the problem. Wait lang, let's troubleshoot this. So I have defined max with a size of 50. It's okay. So what is the problem now? Int A max to max, int B max to max, int product max to max. Wala namang problem. I think sa line 31 at B po ata. Line 31 at B. Ito yung line 31 ko. line 32 at B. Yeah, okay. It should be B, no? Kasi we're talking about the B variable. Okay. So let's say I think sinusundan nyo tong program, no? So let's see. It's still the same, no? What seems to be my problem here? Sa inyo ba nag-run? Nag-run ba sa inyo yung program? O may similar problem din? Let me check. So again, so tama ang aking declaration dito ng variable na to. So it's max. Let's try to define it individually, for example. I think it's also the same. The same problem. So what will be the problem here? Is it I think our brackets naman are fine, but what is the problem here? Okay, let me save it as a C file and run it. Still the same, no? The problem is encountered here. Line 13. Yeah, okay. So kulang nga. Okay. Kulang. Okay, so it's still the same, no? Dito naman siya may kulang sa line this one. So you can see now the problems. If you miss something, no, even some simple symbol that is very hard to see, so you have to check line by line. I think this one naman is the problem. Okay, so we need to put a semicolon here. So I think it's gonna be it. Now it's running. Okay, well and good. So we need to enter the rows and columns of matrix A. For example, the rows and the columns is made up of 3 by 3, and then press enter. Now we need to enter the elements of matrix A. So let's say we have 1, 2, and 3. Sorry. So ulitin natin, napindot ko yung 32. Anyway, pwede rin naman yung 32. Okay? But I want is just a simple numbers muna. Okay, so 3 by 3, enter, and then 1, 2, and 3, and then for example 3, 2, and 1, and then 3, 1, and 2. Okay, now the program is working fine, no? Now we want to test if the column of the first matrix will be equal to the rows of the second matrix, because if they are not equal, the program will not proceed. Okay, for example, we put here 2 by 3, it will say not equal rows and columns, and the resultant matrix is 0. That means we cannot do the multiplication because they are uneven or unequal number of columns and rows. I'm looking at this one, no? This is the column of the first matrix, and this is the row of the second matrix, and they are unequal. So we cannot proceed with the calculation. So we need to put something here that is equal, no? So actually there is a limitation on this. Okay, the limitation is that yun nga, no, na we cannot supply the resultant matrix if they are unequal rows and columns. So again, let's try 3 by 3, and then the element of the matrix again is 1, 2, and 3, and then 3, 2, and 1. Okay, and then let's say 3, 1, and 2. So we need to provide similar matrix, right? So 3 by 3, and then we now enter the elements of the matrix B. So let's say 1, 2, and 3, and then 3, 2, and 1. Sorry for that, I entered right away, no? And then 3, 1, and 2. So this one here is supposed to be in the line here with the 3 and 2. Okay, so but basically they are just fine. Okay, and then I will press enter. So the resultant matrix now is 16, 9, 11, 12, 11, and 13, and 12, 10, and 14. So that is our resultant matrix. Actually, we can try to put some space here in our resultant matrix. So we can put a space here so that the resultant matrix will have a space in between, no? So let's try it again. What if we try for 2 by 2? Can we try 2 by 2? So let's see, 2 by 2, and then enter the elements of matrix A. So we have 1, 2, and then for example 3, 4, and then 2 by 2 again. Enter the elements of matrix B. We have 1, 2, 3, and 4. So that is the resultant matrix. So anything that has equal number of rows or columns in terms of matrix A, and it is equal to the rows of matrix B, we can do that in this program. Now we can multiply and we can have the resultant matrix. Alright? Are there any questions regarding the program? So this is the program that we have created using the topic last time about the multiplication of matrix. Alright, any questions so far? Okay, thank you. If there are no questions, okay, thank you. So we now proceed with our lecture, which is pointers. So what are pointers? So we can define the pointer as a special variable, no? So we can say that pointers are special what? They are a special variables, no? Or special types of data or data type, okay, that is capable of storing some address. So ang ini-store natin sa pointer ay address, no? So it's a special type of data, okay, that is capable of storing some address. Okay, so basically it's very important that when you are declaring a pointer, since it's going to hold an address of the data type, now we need to specify also the type of the data type that we're going to have. Okay, so the syntax for the pointers is somehow typically like this. For example, we need to provide the data type. So the data type can be an integer, it can be a character, it can be a float, it can be a double. Okay, and after that we need to provide a symbol here, which is called the asterisk. No, in some cases, and some people call it asterisk, some people call it a star. No, so we can call it an asterisk, and this asterisk is very important symbol for pointers. Now, without it, we cannot specify that it is a pointer. So this symbol asterisk that you can see from here is a symbol that defines a pointer. So that definitely will be included in the syntax of declaring a pointer. So the data type should be there, and then the pointer name. So that is the syntax, the basic syntax. No? So the data type here refers to the type of the value that the pointer will point to. And the pointer name, of course, is the name of the variable that we are creating. Okay? So that's the definition of the term pointer. Okay? So let's put it here. And then let's paste it here so that I can write something here. So as an example, we can write, for example, an integer. So we can use an integer, no, as the type of the data type. And you can use an asterisk to point to a pointer. For example, that's an example of a pointer. Not only integer, we can also use character as a pointer. So that means the data type that we are pointing to, okay, the value of the data type that we are pointing to the address is an integer. This time it's a character. Alright, so we can use other data types such as the float, the double, etc., etc. Now, to initialize the pointer variable, so we can have an example. Let's have an example here. So we can have an example here. How do we initialize the pointer variable? So let's just copy this one. Okay, and then so this is how we initialize the pointer. So to initialize the pointer, we use the function int, for example, an integer. No? So we declare it. For example, we have an integer called x, and it is equal to 5. No? So definitely, this is a variable, no, that contains 5. But we don't know the address of this one, right? So that means, actually, when we are declaring a variable in C language, what it does, the compiler will have to place 5 into a variable. But actually, what it does inside our computer, the program or the C language put this into a memory location. Right now, we don't know the memory location. No? Ang nakakaalam lang nito, itong memory location na ito, ay walang iba kundi si C language. Okay? So if we want, no, to determine the specific memory address of this particular variable, we need to access that particular location. So if you want to see, for example, so maybe we can display the memory location of our variable. Okay? So we can say that the x variable is located, okay, let's move it here, in address, and then we use %d. Okay, because that's an integer type, we use %d. But instead of using %d, we will use the p. Okay, meaning we will use the pointer. Okay, we will use the pointer so that we will know that that is the memory location. Okay, and then we can use an ampersand, okay, and we are pointing it to the variable. So that means we're looking at the variable, but actually we will print its memory location. So this is how we can access the memory address of this variable. We know that this variable contains 5. There is no problem with that. Logically, x is equal to 5. Okay, there is no argument with that. But we need to determine the address. We need to access the memory address inside our computer. So yours may be different from mine. Okay, so let's try to run this. Of course, we need to save this, declaring pointers. So let's try to print this, and what will be the, yan, see, yours might be different from mine. So x variable, which is equal to 5, is located in this address in my computer. So as I have said, the memory address that is written here may be different from your memory address, but using the syntax, no, that %p, that means we now can access the memory location of this particular memory address. So let's try to add more variables. For example, we put, for example, here a double, no? Let's try double GWA, okay? And our double GWA is equivalent to 1.0. Okay, it's a very high grade, 1.0. And let's say we have a character, and then the character will be a grade, no, which is equal to A, for example. So this is the basic example that we have during the first time that we are programming, right? And I want you to access the memory location of this in your computer, of this variable GWA and this variable grade. Of course, they have different type, no, of variables, no. This is for the doubles, and this is for the character, and this one is for the integer. So we have successfully located this variable x using this command, no. So we can just copy this and paste it here, no. So therefore we want to know the GWA, right? So GWA variable, let's have the small letters. Okay, GWA variable is located in address. So where are we going to locate that? So we need to specify the name of the variable. But this time we're not using %d, but instead we are using %p, indicating that we are looking to the address of the pointer. So basically the pointer, no, is very helpful in locating the address of our variable. So let's copy this also, and let's point, and let's find out the location of the variable, or yeah, the variable grade, which is a character, and let's change it to grade, and then let's run it. Okay, so these are now the locations. You can see the memory locations in my computer, they are not the same, meaning whenever you put or whenever you declare a variable in C language will have to place that in a memory location in your computer, and they have different memory locations. So you can see here that this is the first variable that we declared is placed in FE1C, 62FE1C, and this one is 62FE10, and this one is 62FE0F. Alright? So those are the names of the memory location. These are in hexadecimal format. Okay? So basically, upon reviewing our presentation here, okay, so the pointer is a special type of data that is capable of storing the address or the memory location of the variable that we have declared. And its syntax are the following. Okay? So, another way, so let's try to delete this or exit into this. So, another way to declare and to identify, for example, we have an integer x, for example, no? And it's equal to 5. Now, let's try to delete this so we can have another example. I will try to delete this as well. So, suppose we have an integer or a variable called x, and it is equal to 5. No? So, definitely, we already know the location. How do we know the location or the memory address? By typing %p and accessing the name of the variable that we have declared. Okay? Let's say we have a pointer. No? We can declare a pointer, for example, %p, okay? Or ptr, for example. Okay. So basically, we have a variable here declared, and we have a pointer declared here named as asterisk ptr. Alright? So we can say that this variable, okay, that we have declared can be found in this particular location, and this pointer that we have declared here should have to be placed in another variable, okay, or in another memory location. Suppose, for example, this is in memory 1000, and this is in another memory location. For example, this could be in a memory location called 2000, for example. Okay? So, but actually, we can declare this, or we can make the memory location of this equal to the memory location of this one. How do we do that? We can make the pointer, okay, the pointer that we have declared, we can make it equal to the memory location, okay, of our variable x. Okay? So that means this ampersand sign will mean that this is the address of the operator or the variable x. Okay? So this ampersand symbol. So that means our variable pointer, okay, asterisk pointer, we have declared it here. This is just not a typical variable like this, because it has a asterisk. That means that's a pointer. So we can declare that that pointer will be equal to the memory location. So most probably, the memory location of this was copied, and now it's the same as PTR. Okay, so if we can copy this one, and we can put it like this, so we can say that the memory location of PTR, for example, Let's try lang okay? This is just a trial. So let's see what will happen. So you can see now that they have the same memory location. Okay? So let's try to fix this one because this is correct. So this is for the PTR. The PTR variable is located in what address? Actually, they are now in the same address, no? As you can see from the output. They have the same address. Why? Because we said here in this line 5 that the PTR is equal to the memory location of the variable x that we have declared in line 3. Okay? Now, we also have what we call a value of operator, or we call it sometimes an indirection operator or the reference operator. And that is an operator which is used to access the value that is stored at the location pointed by the pointer. So meaning, in this example, we have an integer x is equal to 5, and we have an integer called asterisk pointer. Okay, so we can now print, actually we can print, okay, the asterisk PTR, no? There is another way also, so let's try to mark this one out, and we can print, so that we can print the using the %d. Okay, so we can say that the asterisk PTR will be the same as the address of the variable x. So you can see it from here. Okay, no, actually we are accessing the content. We are actually using the variable pointer, but we are accessing the content of this variable that is pointed. Okay, so again I will repeat. We declare a variable called x, and we know this memory location, no? By printing it here, we have already know that the memory location of that is here. Now we declared a pointer, and we point that pointer is equal to the memory location of this variable x. Now, this printf function will allow us to access the content of the variable. And what is that variable? The pointer variable, which is equal to the memory location of this variable x. So meaning, this one access the content of the variable x, because we have said that this pointer variable is equal to this memory location. So here, ang labanan dito sa line 5 is memory location. But here, we are actually accessing now the content of the variable. Since hindi na pointer ang gamit natin, we are now using the %d, indicating that that is an integer. Okay? Now, this is actually going to the address of the object. And we can take what is stored in the object. Okay? And what is stored in the object? We have the 5. So if we can change that to 10, for example, our output now will be equal to 10. Alright? So because we have changed the output. Right? What if we change, for example, we change, for example, the value of the object pointed by the pointer. For example, we have 10 here. Okay? And we have an integer here, and this integer will be equal to, for example, our memory location. No? So basically, this is just the same as this one. Okay? And that, for example, we delete this line, and we use the asterisk pointer will be equal to 4, for example. What will be the output of this one? So if we change the operation, okay, our output will be 4, because although this one in the beginning we put it here, but here we change the value of our pointer, which is equal to 4. So it will print the content of our pointer. It's not anymore 10 because of this one. We changed the content of the pointer. Okay? We can also assign value to an initialized pointer. However, this is a very dangerous move, no? Meaning, it is not advisable to assign to a value to an uninitialized pointer. For example, we have an integer pointer here, okay? And then, let's try to delete this. And then, for example, we have an asterisk pointer, and let's say we have that will be equal to 1. Okay? So we will encounter an error here. No? For example, okay, see? So we cannot do this, no? We cannot do that because that will be an error indicating that we cannot assign a value to an initialized pointer. Okay? Now, what are the uses of pointer? For example, what if we apply the pointer to arrays? Okay? How do we apply pointer to our arrays? So this is the topic here, no? Let's say using a pointer, okay, we have a pointer here, meaning this is a pointer to a memory location. Okay? And let's say this pointer is pointing to the first element of this array. And this array has how many elements? It has 8 elements, no? This is the first element, which is the 0th element, first, second element, third element, fourth, fifth, and so on. So using the pointer P, how do we point to the first element of the array? So we do that by declaring the pointer P here is equal to the memory address of our array, which is A, and pointing it to the first element of the array. Typically, this is basically the same as this one. No? I have a program here. So let's say, so in the example, we have 8 elements, right? So I need to add some more elements here. So let's have 0 as our first element. Okay, the 0th element. So and then we have the pointer P. So this is our pointer P. And then let's declare that this pointer P, as written here in the presentation, pointer P should be equal to the address of our first element. Okay, so let's try to print our asterisk P. Okay, so what will be the content of asterisk P? So any guess? Any simulation guess? Ano ang magiging laman ng ating asterisk P? If we try to access asterisk P, what will be the content? So in this particular example, what will be the content? Okay, the answer of your classmates are 0. I think that's gonna be correct. So if we try to run this one, so 0 is the answer because the first element, no, pointed by this expression, no, at A or at array 0 element, it's pointing to this particular memory location. Okay, and we are pointing that to this location. So now, if we try to change this to P, okay, so definitely we're doing it in this memory location. Okay, that's the memory location that we're putting it. Okay, so from this example, we are actually pointing it to this memory location. Okay, but let's say what happens if we add some integer to the pointer. So what happens is that if P is equal to P plus 3, this means we have to move the pointer from this location. We will move the pointer 3 positions in forward direction. So that will be equal to P, which is the current location. We move it with 3, 1, 2, 3. So this will be the result of P is equal to P plus 3. Okay? So that is the result. No? That means we are moving the pointer from this location, adding it with 3, 1, 2, and 3. That is the position. We are moving it in a forward direction. So that means, okay, if P points to A's of I, no, then P will be equal to P plus J, which is equivalent to at address I plus J. So what is the meaning of this? Let's say in this example, A, the original location of our pointer is this, right? And that is A to the element 0, the array in the element 0. Then that is equivalent to P, which is equal to P plus 3. Okay, that is equivalent to this memory location plus 3, which will be equal to this memory location. So that means if the memory address, okay, is equal to 1000, no, this one, okay, accessing the memory location of this array element, now the pointer is pointing to this memory location, which is 1000. So therefore, if it is equal to P is equal to P plus 3, we are moving 3 steps. Okay, the memory address now will be 1012 because the memory address of this element is 1012. Typically like this, no? Why is it that the equation is equal to 1000 plus 1 times 4? Because as you can see, the interval of each memory location is 4 bytes. Okay, so the first one, the first memory location has a value of 1000. The beginning is 1000 and the end is 1003. Okay, and the beginning of the second element is 1004 and the end is 1007. So basically it's made up of 4 bytes. So when you compute for P is equal to P plus 1, you'll have to specify this as P is equal to 1000 plus 1 times 4 because the number of bytes per memory location is 4 bytes. So the next memory location will be equal to 1000. We're pointing at this. That will be equal to 1004. Alright? If it is P plus 3, it's going to be 1012. Now coming from the original position, which is 1000. So looking at that, let's try to analyze this and let's remove this. So in the beginning, the pointer is pointing to this, right? So what if we add 1? Okay, what will be the content if we add 1? So that means if we add 1, we are moving the pointer towards the positive direction. Therefore, we are accessing the next element, which is this one. Okay, so let's try to run. It should have the answer 1, and it's correct. So we have the answer 1 here. Okay, what if we add 5? What will be the content? So this is the original. We move it forward by 5 times. 1, 2, 3, 4, 5. So this will probably be the answer. Okay, it should be 5, and it's correct. So basically, it's the same, no? What about this one? Let's say we have a pointer P and an array A, and initially the P contains the address of the third element of the array. So this is the initial, no? Meaning, at P, we have the initial is the third element, which is equal to, not A is equal to 0, meaning we are accessing the third element. And what is the third element here? The third element here is this one, no? This is the 0th, first, second, and third. So we are talking about this. So 0, 1, and 2. Okay? 0, 1, and 2. Okay. Anyway, this is the fourth element pala. So this is the third element. So I'm confused about the numbering. Actually, this is the 0th element, first element, second element. Okay. Now we're accessing this one. 0, 0th, first, second. Okay. We are accessing actually the third element. So therefore, this is our original location. And the question is here, what will be the index of the array after this operation? Okay, P is equal to P plus 2. So therefore, if we want to access this, so that's going to be moving forward 2 times. So therefore, the answer should be equal to 4. Okay, let's see. It should be equal to 4. So it's correct. So that's how we use pointer in arrays. Okay? There are also some discussions about subtracting an integer from a pointer. It's basically adding an integer from a pointer, no? And for example, if our original location is this one, okay, which is equal to this. So how do we do that? So basically, from subtracting, we are just moving it backwards naman. Because we are subtracting it from the pointer's location. Okay, so if we try to do that here, okay, P minus 2, for example, okay, so what will be the content after this subtracting an integer to the pointer? So our original location is this one, and we subtract 2. What will be the content? So the content, I think, is going to be 0. Okay, so that will be how subtraction of integers are actually happening when we try to do the subtraction of integer from the pointer. Okay, so basically that's the explanation there. So what about if we use the post-increment? Okay, so what is the meaning of post-increment? The concept of post-increment is that we do the increment first, and then after that we assign the value. So you know the concept of increment, right? We are adding plus 1 to the value of the variable. But we have what we call a P++, and that's a post-increment. And also we have plus plus P, and that is the pre-increment. Now in this example, let's try to copy this example, no? And let's try to evaluate. No? So we have the following values such as 5, and then we have 16, we have 7, okay, and then we have 89, 45, 23, and then we have 10. In the beginning, the pointer is pointing to this location, to the original location, which is the first element. We are pointing to the 5, right? So we want to print, okay, let's try to do that. Okay, we want to print, let's try to remove this, okay, the %d of our P, but this time we're going to have a post increment. Okay? This is the post increment. So what do you think will be the value of our P here? Okay? So let's try to run. Okay, so this is wrong, I think. So we need to, okay. So we need to print another one here. Print F %D, and then we need to print our P. Let's have this one. So let's have this, and then I think kulang tayo ng asterisk dito. And let's try to run. What will be the value? So the value now is equal to 5 and 16. So let's try to have this \n. So in the beginning, okay. So this is the the concept of the post increment. Okay. So from here, so if we want to print the original location, no, let's try to print first the original location. This is the original location, no? This is the original location, which is pointing to 5, right? And then after that, we will do the post increment here. The post increment, and then we'll do again the original. Okay, so let's try to print that. So you can see that using the post increment will allow us to print this is the original, which is 5, pointing to the original location. And when we do the post increment, the value of the pointer is pointing to the original. Okay, so definitely what the post increment does is that it gives us the value before it increments. Kaya nga siya tinawag na post increment. Ina-assign niya muna yung value, no, which is the original value, and then after that nag-i-increment siya. So kailan magte-take effect ang increment nito? When we do this function, this execution. Okay, we do this execution. Right? So, ang magiging result natin dito is 5, 5, and 16. So, because in the beginning, we have the 5, pointing to the 5, and then we do the post increment. In the post increment, it will only point to the original location, because the increment will happen when we execute this. Okay, so that is the meaning of post increment. Okay, so this is just an explanation. I already explained this. Okay, what about the pre-increment? No, kunyari baligtad naman. Okay, so what will be printed if we try to reverse? No, this is now the plus is put here when we remove it here. No. This is what we call the pre-increment. This means that the increment will happen first before we assign the variable. So let's see what happens. So in the beginning, we have 5. As you can see now, the result is the original is printed here in the first, or line 6. And in line 6, 7, okay, it will do the increment, no? Because the increment happens before the placing or the assignment of the variable. Okay, and then we print here. What will be the result? Actually, there is already a result here because it already incremented. Okay, it already assigned because the variable here P will now be 16, no? So the answer is 5 and then 16 because it incremented the value here. And finally, the final value of our pointer will now be equal to 16 because it's now pointing on this particular element. Alright? Any questions so far? Any question? Okay, clear naman, ano? Okay. Okay, nagigets nyo. Okay, very good. Now, this is just an example. Okay? I will be posting this in the module, no, so that you will have an idea. Okay? What about the pre and post decrement? So basically, the post and the pre-decrement is similar to the concept of increment and post-increment and pre-increment. However, this time, we're doing it the opposite way. Okay, for example, we are pointing in 5, no? Which is 5 here. What is the answer for 5 here? So we have 0, 1, 2, 3, 4, 5. So the original location now is this pointer. No? The pointer now is pointing on this. This is the element 6. Okay? For the element 6. Let's say this is our and then we command our program that the pointer should have a pre-decrement. Now, what will be the original location? Okay? And let's say we have a pre-increment here, and let's have a post-increment here. Okay, what will be, so our original is 45, right? So what happens if we do the pre-decrement, and after that we do the post-decrement? So let's run. So in the beginning we have the 23 here, no? We're accessing the original pointer's location. But when we do the pre-decrement, no? The pre-decrement gives us the value 45. So that means when we do the pre-decrement, it subtracts the value of the pointer by 1. Okay? And then after that, it assigns the value to the pointer, which is 45. Okay? And then we do the post decrement. No? Why is it that it's still 45? There is no decrement here. It will happen. No? You will see now that the value of the pointer now is still pointing on this location. Okay? Why? Because there is no decrement happening here. It will only happen if we print again, if we do another execution of this particular command. No? Makikita nyo mag-iiba na yung pointer natin kung saan nakaturo. See? Okay, so sorry for that. Let's have a... You will see now that here, di ba original natin 23, nag-pre-decrement tayo. So 45 na siya. Nag-post-decrement tayo. Bakit 45 pa rin after this? Because we can only it only assign the value of the pointer, but it did not make the decrement yet. It will have the decrement yet after another execution of a particular line. Okay? Kaya nakita nyo rito, yung susunod na value natin ng 89, nag-decrement na siya, no? Hindi na siya 45, 89 na siya. So originally we have 23, pre-decrement 45, post-decrement 45 pa rin. At kailan lang siya magkakaroon ng change? Kapag pinrint natin yung value ng pointer now. Now the pointer now is pointing to 89 because nag-take effect na yung post-decrement natin. Okay, so that is the meaning of P++ or P minus minus and plus plus P and minus minus P. The post and the pre-increment and decrement. Any questions so far? So this is just the example. Okay. Kung wala, okay. So I think we can stop from here. I need to stop the